July 25, 2000. An Air France flight taxis down the runway at Charles de Gaulle Airport in Paris. It was just a normal day at the airport until suddenly it all went wrong.
Good evening. 113 people were killed today in the first ever crash by a Concorde.
This was the day that it all went wrong for Concorde, the world's most iconic commercial supersonic jet. And just 3 years after that incident, the Concorde took its final flight.
Taking off into a New York sunrise, BA002, the last supersonic passenger flight to cross the Atlantic.
BA Flight 002 from New York touched down at just after 4 this afternoon. It was the last of 3 Concordes to land at Heathrow today, ending one of the most glittering achievements in aviation history, supersonic passenger travel.
Welcome to Moonshot. I'm Christopher Lawson. And since that final Concorde flight, the world has not experienced the joy of supersonic passenger travel. But this week on Moonshot, we're going supersonic, diving into the new wave of companies that are trying to bring the idea of a supersonic passenger aircraft back from the dead. But before we cross that sound barrier, here's a word from our sponsors.
Well, it had always been the dream of aircraft designers, and for that matter, people who flew on airplanes as well, to go as fast as humanly possible. And for the longest time, they thought there was such thing as a barrier, as a sonic barrier. There really wasn't. That's all a matter of physics.
This is Bob van der Linden, the curator of air transportation at the Smithsonian National Air and Space Museum in Washington, D.C. Bob had the opportunity to fly on the very last Concorde flight from Paris, which was making its way across to the museum.
The press was out there. There was a lot of commemoration and I guess celebration, because they're celebrating the 27 years it was in service, and a little bittersweet. But they had the fire trucks out with with the jets of water over it. We had a French Air Force Mirage escort us to the coast. All the press was there. It was very nice. It was great. But it was, the last flight.
The Bell X-1 was the first manned aircraft to travel supersonic in 1947. And it didn't take long before several countries started a push to develop commercial supersonic transport, or SSTs. This push all came to a head in the 1960s, along with the big rush of development in the aeronautics and space industries. This was the age of the moon missions, and at the same time as we were trying to put a man on the moon, people were imagining what a commercial supersonic plane would look like. And although the Russians were the first to fly a supersonic transport aircraft in 1968, it was the Concorde, a joint project between Britain and France, that really captivated the world's attention.
For Concorde 001, this was the chance to prove she was the super bird everyone had hoped and worked for.
Concorde first took to the skies in 1969, before entering commercial operation in 1976, flown by both British Airways and Air France.
They were champagne days for Concorde. There was a queue to fly in the most exciting aircraft the world had ever seen.
The airline could travel at almost Mach 2, meaning it was flying twice as quick as the speed of sound, resulting in trips that were more than twice as fast as your average commercial jet, which travels at subsonic speeds. And it was this ability to move at such high speeds that attracted a particular sort of wealthy individual.
And I mean very wealthy, or businessmen, business people, I should say. But again, we're talking CEOs. We're not talking mid-level managers here, because it was expensive. In 2003, when it was retired, it cost $6,000 US to fly one way. That is a lot of money. That's a lot of money today. Significantly more expensive than first class. And yes, it was, took half the time, but a lot of the very wealthy didn't think it was worth the money. Just hop on a big, comfortable 777 or 747 or a nice Airbus, sit up. If you're wealthy, sit up front in first class, lean back and go to sleep, and wake up in London, wake up in Paris.
When you would go on board a Concorde, What was special about the experience apart from the fact that you were flying really fast?
I have to be honest with you, that's it. Yeah, the airplane itself is very small. It only sat 100 people. You got 4 across seating. The seats are about 17 and a half inches wide. The width of the seat is the same as in coach. You do have leg room. But you're in a small tube. It's almost like being in a commuter jet. You know, it's much smaller. There's no in-flight entertainment. Well, there was. You just watched the Mach meter up on the wall, which was a lot of fun, believe you me, watching that go up. Now, tiny windows, but you can see out them very well, but they're right next to your head. Now, superb service. And, it's the best. When people complain about airline food, it's like, well, yeah, it's generally pretty bad, but not on the Concorde. Believe you me, it was magnificent. I was on Air France, and the flight was about 3.5 hours, and a proper French meal takes 2.5 to 3. So by the time we got the cruising altitude, we were served our dinner. Or actually, it would have been lunch, but it was soup to nuts. And by the time we finished, you look out the window, and we were about ready to land. So it was very, very nice. I loved it. Believe you me, it was great.
Concorde was a marvel of engineering, with its beautiful delta-winged design and a nose that could be lowered to allow the pilots to see the landing. But it faced a number of issues. Firstly, the cost of operating the aircraft. Flying at supersonic speeds used an awful lot of fuel, and the resulting ticket prices meant that not everyone could afford to fly. And those that could afford it expected that they would be getting onto a Concorde flight, which meant that there was always one plane sitting on the tarmac as a backup, waiting in case something went wrong. Secondly, it was restricted by the routes it could fly due to the noise generated by the aircraft. And also the high fuel usage meant that it wasn't good for trans-Pacific flights. And thirdly, it had a huge environmental impact. So while the Air France crash may have been the beginning of the end for Concorde and has left a lasting memory in people's minds, it certainly wasn't the main issue facing the aircraft when it was put into retirement.
Air France in particular knew that it was probably the right time for it, because Airbus, which was the successor company to the manufacturers of the Concorde, had earlier announced that they could no longer support the airplane. At that point, there were only 12 in service, and spare parts were getting scarce, and making new ones was outrageously expensive. And there really wasn't a market for it. So Airbus pulled the plug on it, and Air France and British Airways, the only 2 airlines that ever operated it, had to retire them.
Concorde really was a pretty fantastic technological achievement, especially for the time. It's amazing, really.
This is Peter Cohen. Peter is project manager for NASA's Commercial Supersonic Technology Project, which is specifically looking at ways that you can redesign a supersonic aircraft to reduce the impact of the sonic boom.
Yeah, if you look at some of the issues that Concorde faced, those really are still the barriers to supersonic flight, and we tend to put them in 2 categories. One is environmental, and those are things like the noise from sonic booms, noise around the airport when Concorde was taking off and landing, and high altitude emissions. And the other group of barriers is really efficiency, and that really comes down to fuel consumption and essentially passenger miles per gallon, how efficient the airplane can move a large number of people. And that also gets into how efficient the aerodynamics are, how efficient the engines are, et cetera. And then finally, how does it operate in the airspace system so that it can make best use of its speed? So since you look at Concorde, we want to make it cleaner and greener and more efficient.
Now, this idea that NASA is working on to reduce the impact of the sonic boom is a really big one, because in the United States, Europe, and many other places around the world, flying over land at supersonic speed is banned because of the feared impact of the sonic booms. And it's this restriction which had a heavy impact on the economics of the Concorde.
Because of sonic boom, most nations would not allow the airplane, any SSC, to fly over land. Well, once you do that, you just eliminated half the routes around the world. So and therefore you just eliminated a huge market for the airplane. No domestic U.S. airline going to buy one if you can't fly it, supersonically. What's the big deal?
But NASA is keen to see supersonic transport back in the skies and plans to overturn this by designing planes that can actually reduce the impact of the sonic booms.
People have been studying sonic boom essentially since the first one was heard, trying to figure out what it is, and then pretty much as soon as they understood that, how to reduce it. So the math and some of the concepts for shaping an airplane so that it produces something other than the typical boom boom of a sonic that's heard when a supersonic aircraft flies overhead really goes back to the 1960s and early 70s. But more recently, within the past 10 years or so, we really think we've made a breakthrough in terms of how you would shape the airplane to distribute the shock system so that the shocks don't coalesce and pile up on top of one another, resulting in a sonic boom.
Sonic booms, as Peter mentioned, are caused by a buildup of sound waves when flying faster than the speed of sound. They aren't caused by this idea of breaking the sound barrier because, as you've already heard, there isn't really such a thing. However, they aren't actually heard until you're flying at around Mach 1.1. And yes, we also said sonic booms because sonic booms are heard constantly throughout a flight. So it's more a series of booms that are heard on the ground rather than one individual boom.
If you think about it, air takeoff and landing noise affects people around the airport. But a sonic boom, essentially, as soon as the airplane exceeds the speed of sound and begins to cruise at supersonic speeds, it's constantly making a sonic boom. So everybody under its flight path is exposed to that sound. So it's really important to us to get it down to the point where in some conditions, you may not even hear it on the ground. If I'm standing outside my office and I'll hear a sonic boom when the airplane flies over, if you're 20 miles away, when the airplane flies over you, you'll hear exactly the same sound.
And NASA is actually building a plane in partnership with Lockheed Martin, which will be designed to specifically reduce the sound of a sonic boom from a boom to more of a thud.
If you're in a thunderstorm and the storm is right overhead and you get the lightning flash and the thunder right at the same time, that's a sonic boom. A little while later, the sun's come out. There's the storm is off in the distance, and you hear that kind of faint rumble of sound. That's a sonic thump. That's what we're going for.
The contract to build NASA's prototype plane is worth almost $248 million US, and the plan is to have this plane in the air by 2021. Assuming all goes well, if NASA can prove that it's actually possible to reduce the impact of a sonic boom to an acceptable level, they're hoping to reverse the current legislation and open up a market for domestic supersonic transport.
NASA is working with the FAA and the International Civil Aviation Organization to develop the framework for a certification standard for supersonic overland flight. So, in other words, how do you, if you came forward with a design that you said was quiet enough to fly overland, how would you prove that to the certification authorities? So we're putting that framework in pieces. Now that standard, as they call it, will generally have a metric, something that kind of the number that you have to show them, and a procedure for calculating that number or recording that number, and a limit. So this is where our research comes in. We want to provide the FAA and the ICAO with a database of response to sonic boom sounds from people on the ground that allows them to say, at this level or below, the airplane is quiet enough that it will be allowed to fly overland at supersonic speeds. So really, our goal in a success to NASA means the ICAO and the FAA and the other international rulemaking organizations have the data they need to change the rules about supersonic overland flight.
And if NASA can successfully overturn this issue with domestic supersonic travel, it should certainly open up more opportunities for commercial SSTs. But that hurdle around domestic flight isn't stopping a new wave of companies from taking on the challenge of supersonic transport. And we'll have a look at one of those companies right after this break. Welcome back to Moonshot. I'm Christopher Lawson, and as I mentioned before the break, there's a new wave of companies that are taking on this challenge of building a supersonic passenger jet. And one of the leaders in this race is a Denver-based company called Boom.
I went to Amazon shortly after school in 2001 when my parents thought it was still a bookstore, and kind of had a career, working in areas where everything was getting faster and better. Our computers, our communications, even how quickly we can get things delivered to us when we shop online. But weirdly, with airplanes, it's a very unique story in the history of technology that we had a capability in Concorde, and instead of taking it more mainstream, the way we've done with everything from electric cars to cell phones, we actually stopped and went backwards.
This is Blake Schul. He's the CEO and founder of Boom Technology, a Denver-based company planning to bring back supersonic transport in a really big way. Blake is a computer scientist by training. He's worked in a number of successful startups, including Amazon, and founded a company which later sold to Groupon. And around 4 years ago, he sat down and started sketching out ideas for what his next company might be.
What I realized in thinking about what I wanted to do next was that all startups are hard. There's no such thing as an easy one. You're going to go through hell. And so what you need to do as a founder is pick a mission that inspires you enough that you're never going to get up in the morning and say, why am I doing this? It isn't worth it. You're always going to keep going. You're never going to give up.
And because Blake is fascinated by aircraft, at the top of Blake's list of ideas to work on was something with wings.
If you look at Concorde, it was a massive technical success, but an economic failure. Tickets cost $20,000 round trip New York to London in today's dollars, and you just can't fill 100 seats like that. And the fundamental reason that the cost spiraled out of control was that the fuel economy is poor. And so if you start saying, well, okay, everyone says it's a massive leap from Concorde to make supersonic travel available at economy prices. But there's this thing called business class, which is 10% of seats, but half the revenue. Well, what would you have to do versus Concorde to match business class kind of fuel economy and business class kind of pricing? And it turns out the answer you can get from a 3-line spreadsheet you can build out of Wikipedia, and it's 30%. So if you can beat Concorde's half-century-old technology, remember, this thing was designed with slide rules and wind tunnels on drafting. If you can beat that by 30%, then all of a sudden you can have a second-generation supersonic transport that gets you there in half the time, but at the same fares you pay in business. And so once I realized that, I thought, well, that doesn't sound impossible.
Now, let's not forget that Blake is a computer scientist. He wasn't an aircraft designer. So back in 2014, he started reading as much information on aircraft design as he could. He bought textbooks and he even took a class. And after a while, he knew enough that he put many of his ideas on paper and then took them to a professor at Stanford to check if all of his assumptions were correct.
And he looked at it and clicked around and said, Blake, if you're going to do this, you should really try harder because all these assumptions are conservative. And so at that point, it was very much either you have courage or you don't. And if you do, you're going to go for it. Now, it turns out he was wrong. The assumptions were aggressive, and it's incredibly hard to get to them. But neither of us knew that back then, so the company got started.
That courage to dive right in led Blake down a path to building a team.
A lot of people told me I was crazy, that this could only be done by governments or militaries, that you certainly couldn't do it as a new company, that it would take too long and cost too much money, it would be too hard. And there are a whole bunch of standard false assumptions about what startups can do, as well as what's possible with airplanes. But you'd also, you judge them for, do they make sense on their own terms? A bunch of people told me, well, you can't do that. It requires variable geometry in the engine intakes, and that's really hard. you stop and say, well, wait a minute, the Concorde did that. And, I may not be an aerospace engineer, but I'm pretty sure if it's been done before, it's not impossible. And so, you'd find the people who could stop, put aside the traditional wisdom and say, well, let's just look at this from first principles and say, what would it take? And then you find a way through.
Designing aircraft is hard. It takes a lot of time and money to get right because there's an awful amount of complexity in the build, and you need to make sure it's safe, which is why there's really only two main manufacturers of commercial passenger aircraft, Boeing and Airbus. So how does a startup like Boom actually get off the ground and get to the point of delivering a production-ready aircraft?
What we decided to do is, rather than going straight into production on a 55-seat, 200,000-pound Mach 2.2 supersonic transport, which will be, frankly, one of the most sophisticated safety-critical machines ever built. You say, well, let me go build a subscale prototype, something a little bit smaller, but the same speed, and let me go prove this is possible in a reasonable amount of time with an obtainable amount of money. And so that's what XB-1 is. It's a 1/3 scale version of our first passenger aircraft that will go fully Mach 2.2. We'll do it with a pilot and one passenger, and we'll prove that you can do this as a startup. It's akin to the Spaceship One for private space.
Now, the XB-1 is really a proof of concept. If Boom can prove that their technology actually works on a small scale and show that it is significantly more efficient than the Concorde, it will be much easier to lock in all the financing needed to put the aircraft into production. Boom has raised almost $50 million, including a $10 million investment from Japan Airlines, and Virgin have also registered interest in purchasing the aircraft. The price is set to be around $200 million, but they already have around 80 pre-orders for a plane that hasn't even left the ground. But the team is making good progress and are on track to have the XB-1 prototype in the air next year.
The horizontal tail is in the hangar, the nose is getting built. I just looked at our inventory room over the weekend, and the wheels and the tires are here. So this is well on its way to becoming an airplane. We've hired the test pilot who's going to fly it, and that bird's going to be in the air towards the end of next year.
And once they've proved the prototype, that begins a 6-year design, development and approval process before the aircraft can be put into production. But all going well, Blake is hoping to have Boom's first SST in service by around 2025.
Airplane people say, wow, how can you do it so fast? And non-airplane people say, why in the world does it take so long? And to answer kind of both of those, the reason it's only 6 years is that all the technology for this already exists. We're not counting on any kind of new materials or new aerodynamics. This is stuff that's been proven out on other aircraft. The aerodynamics are an optimized version of what flew on Concorde. The materials were proven out on the 787 Dreamliner. The engines are an adaptation of the same stuff that powers every modern large airliner. And so you're doing an engineering and safety testing and regulatory approvals process rather than a science project. And that's really huge. And that for making this feasible, and I think that's the basic answer to why this is actually happening now, finally. But it takes a long time because it is safety critical. There are many, many, many parts on the airplane, and airplanes don't have optional parts. They're all needed. And we're putting 55 souls on it. It has to be rigorously tested so that day in and day out, it is safe and the kind of airplane we would trust for our friends, our family, and our loved ones.
One of the issues with Concorde was that much of the body was built with aluminium, which doesn't really handle well at high temperatures generated when travelling at supersonic speeds. In fact, the aircraft would actually change size while it was in flight, which in many ways Concorde actually handled in a really fantastic way, but it is an issue that Blake says can be eliminated through the use of modern materials.
Concorde would grow 15 inches in flight just from the heat. And let me tell you, it's a tricky thing to go off and design an airplane that's going to get bigger on the outside while staying the same size on the inside, and it's supposed to be airtight. But carbon composites basically don't grow, very, very slightly, and they can handle higher temperatures than aluminum, which is what enables us to go faster than Concorde did. So Concorde is Mach 2.0, we're Mach 2.2, so about 10% faster.
As I mentioned earlier in the show, one of the issues with Concorde was that it was very limited in the routes it could fly due to the bans placed on supersonic overland flight, and also it didn't have the fuel capacity to make trans-Pacific flights. But Boom is not really concerned about the domestic flight problem because they're focusing on highly travelled international routes where there's no real issue with travelling at supersonic speeds.
So routes like San Francisco to Tokyo, Seattle to Shanghai, Boston to Paris, routes where you can fly 90% plus over water. And the whole question of is the sonic boom a problem is just moot. That said, personally, I think the sonic boom problem is exaggerated. There's a great episode of Mythbusters where they test the myth, can you break a window with a sonic boom? And it turns out the answer is yes, but you got to fly 50 feet over the ground supersonic and put the boom smack dab in the middle of the window. And and let me tell you, if you're 50 feet over the ground supersonic as an airliner, you got a bigger problem than a broken window.
Have you personally flown on a supersonic plane?
No. I've been on Concorde, but only in museums. And, I kind of gave myself a life goal in my mid-20s to go Mach 2. And I put a Google alert on supersonic jet because I wanted to be first to know when I could go do that. And after enough years going by of seeing no credible effort, I thought, well, sheesh, if I'm going to do this, I might have to start the company and build the jet to make it happen.
You're now 4 years into this journey. What's the biggest thing that you've learnt through starting Boom?
I think it's that big, inspiring missions have a way of being easier than smaller ones that look like they're actually easier. And so let me unpack that for you. My last company was a mobile e-commerce software company, the kind of thing that you'd think would be really easy to do. But man, it was hard to hire people. It was hard to convince them why they should come work with us and how we're different from the million other apps in the App Store. And it was, and you get up in the morning and wonder why you're spending your life on this versus you can work on supersonic jets. And especially if you can articulate to people why it matters to the world and why it's going to be a better place to live when you can get around the planet more easily. You can get some amazing people to come work with you. We have a guy from SpaceX who previously owned the upper stage of the Falcon 9. We have a guy from Airbus who owned the wing on the A380, which is the largest commercial wing ever built. We have a guy who owned propulsion on the SR-71 Blackbird at NASA. I could keep going. And if I were working on an all composite business jet or some less important idea, I would never have this team. And then when you can collect a whole bunch of great people, all of a sudden these grand challenges that look like they'd be nearly impossible start to become very possible.
Thanks for listening to Moonshot. If you enjoyed this episode, please tell a couple of friends. Sharing is caring after all. And don't forget to check out our sponsors. You'll find links in the episode show notes. Moonshot is hosted by me, Christopher Lawson, and also Andrew Moon. Research for this episode by Mahalia Carter. Our cover artwork is by the incredibly talented Andrew Millist, and the theme music that you're listening to right now is from Breakmaster Cylinder. That's all we have this week. Join us again next week for another episode of Moonshot.